Hello, everyone. Thank you very much for being here. For some of you, very early, and some others very late. And today we have the privilege of having a conversation with Jennifer Rexford, professor at Princeton and also provost at Princeton. And this conversation is led by Professor Nick McKeown from Stanford University. And it's on a similar model as the previous session organized with Amin Vadat, where Nick was interviewing Amin. We thought that it was very successful, very interesting, and we decided to, thanks Nick, organize another one and maybe more. So the novelty on this one is that the conversation between Nick and Jen has been pre-recorded. So today you will see a 20-minute presentation. There will be also, how long is the other one? 70 minutes? 76 minutes?
It's actually 40 minutes and 70 minutes. So it's a 40-minute, not 20-minute that you're down.
So 40 minutes today, and it will be followed by a Q&A session with Nick and Jennifer live in person. Okay, so I think we can go ahead. Thank you very much to the presenters and the speakers, and we can move forward with the presentation.
I'm pretty sure I first met Jen, I think it was 29 years ago in San Francisco at Infocom in 1996. We'd both just finished our PhDs. Jen was at Michigan and I was at Berkeley. Jen was presenting a paper titled Hardware Efficient Fair Queuing Architectures for High-Speed Networks. I was actually already a dyed-in-the-wool hardware weenie. And by 1996, it was pretty clear that the internet research community was moving away from hardware and EE and towards computer science and computer systems and software. And as a new assistant prof, I was already getting a bit lonely as an internet hardware person, even back then. Infocom was good, but it was starting to be eclipsed by SIGCOMM even then as the best networking research venue. And SIGCOMM was already a bit kind of cliquey and full of itself, to be honest, even back then. But there in San Francisco, at Infocom, was Jen, a super articulate, fast-talking internet hardware weenie just like me. Here was someone talking about different hardware implementations of fair queuing. I had instant respect and kinship, and we've been friends and colleagues ever since. So I'm going to start by asking her about her background and then see if we can understand how this shaped her career path and her choices and the ups and downs along the way, as well as how she sees the world of networking systems today. I think that will be interesting to all of us. One thing I think you're going to notice about Jen very quickly is that she thinks fast, she thinks on her feet, and she's always super thoughtful. Can you start by telling us a little bit about you, your origin story?
Yeah, so my father was spent his career in the Air Force as a Korean linguist. And so we moved around a lot when I was a kid. I used to joke, we always moved only halfway around the world each time we moved. So we lived in Hawaii twice, in Korea and Japan, and the DC area 4 times. So I consider the DC area home, but we sort of were back and forth quite a bit when I was a kid. My mom, because of all the moving, was a stay-at-home mom until I was in late high school, and then she started working as a college counselor at the local high school I went to. So she was involved in education. And I would say one thing that was noteworthy, my parents both really valued education. The moving around was challenging because I was changing schools constantly, but there was the continuity in the focus on education. And in some cases, a lot of time learning on my own, because I would arrive at a school behind in some things and ahead in other things. So there was always a certain amount of chaos with my education. So there was a lot of catching up and slowing down that went on with my education throughout the time we were moving.
It was sort of right in the middle of that .com boom. And I remember Mike Odell, you remember this? He was saying, if you aren't scared, you don't understand. And there were all these claims that the internet was doubling every 100 days. Yep. As we all know, it turned out wasn't true at all, but which is something for us all to bear in mind in this day and age of hype about AI. We should remember that. But they were getting pretty giddy, heady scary and exciting times for those of us working in networking, weren't they? And you were right in the thick of the biggest networking company, right, in the world, working at AT&T Research. And what was it like? Can you give us a sense of the excitement, the fear, the sense of responsibility to society for this new incredible technology?
Yeah, I mean, what was particularly exciting, I kind of hinted at it earlier, was just interacting with practitioners who are really making it all work with duct tape and baling wire. I remember I spent a lot of time talking with some of the folks at AT&T who had worked on the telephony network, and they would say things like, well, how do you know if you get the topology and the traffic matrix for the network, how is the routing going to work? And they would ask these well-posed questions, and I'd be like, golly, that's a good question. And we don't think about it that way. Like, we just have these protocols and they do their thing.
This kind of works.
And it was, so for me, it was kind of sobering that I remember some of them would say, Jenna, we're betting the company on this. You know? And what do you mean it's dropping packets? Like, you should never drop a packet. Like, what?
And I think in some ways this sort of must have framed all of the interest and work that was going on at ATM, right? Because the telcos were looking at this toy cowboy internet thing and saying, you know, come on, we need a grown-up network. Let us come in and manage and engineer it in a way that we're used to doing. And, conveniently, of course, the telcos would have been in charge and making all the money. It's kind of interesting thought experiment to think how the world would have been different had that actually been what happened. But and the future was going to be carried in 53-byte packets. Remember, people would have badges that said 53 with a line through it. So this is something that they didn't agree with. Can you capture for us the main arguments that were being made for or against ATM at that time in that context? Because it was, no one knew whether, I think we probably all assumed it was going to be the dominant network technology, and how that debate in particular was playing out inside AT&T.
So for me, ATM was kind of the gateway drug from parallel computing hardware to what later became internet routing hardware for me. So at first it was just like, oh, that's a good segue for me. And I think a lot of it was based on a number of assumptions. One is, hey, the packets need to be really small because we can't tolerate the sort of delay that comes from large packets getting ahead of a time-sensitive voice packet, for example. So some of it was an assumption that the multiplexing had to take place on a super small time scale because of latency. Not really true, but I think there was a perception at the time we would need echo cancellation equipment for voice if we didn't. It's funny to think of it now, right? But there was worry we'd need nationwide echo cancellation equipment if we didn't have ATM. That's right. Some of it was that the packets had to be parsable really easily at high speed. That's why the header formats had to be fixed and simple and not hierarchical addressing, and because somehow hardware wouldn't be able to process at speeds. Again, not accurate. And some of it was this mindset, gee, we need to be able to manage the network. We need to be able to know what resources we need. We need to know what performance we're going to offer and be able to have a kind of top-down way of reasoning about it. And the internet was so not that.
Yeah, I think those of us outside of the telcos rather assumed that the telcos were populated by people in suits who were sort of counting the numbers and sort of saying, well, if this happens, we're going to lose all of this money. And that somehow you were all kind of told inside the telcos that you must speak this language, otherwise we're all going to go bankrupt. My guess is that the techie people were not thinking like that at all inside AT&T, but there was a certain mindset that just came from years and years of experience of building networks a particular way that worked, because telco networks had to work by law. And so, it sort of framed the conversation. So it set up these sort of opposing viewpoints between the telcos and the internet folks who were considered the crazy revolutionary. So
there's so many meetings I was at early at AT&T where someone from the sort of bellhead side of the company, if you will, would say, well, there are 5 things that matter: reliability, time to market, and cost. And if you can't do all 5, just do the first 3. And that mindset was really there. And of course, the internet is just the opposite.
Of course.
Of this. So it was just such a deeply embedded mantra. And I think a lot of my time at AT&T was, and I'm making fun of the bellheads, but at the same time, a lot of my own work was taking the good things about, needing to think rigorously about management of resources, or, needing to think about the control plane of a network. So a lot of my work was trying to distill what I thought were actually good lessons from the telecom network, and to figure out which ones were not applicable to the internet. It was, there's subtlety there. And I certainly made mistakes along the way in how to think about it. But I do think being there at that time and witnessing that culture clash was quite informative to me. So I tried to take what I thought was good and leave what I thought wasn't.
Well, it takes me to quite nicely to the first of your papers that I wanted to ask you about, and that was it was the late 90s, and you started to work on BGP, and then in 2001, I think it was, you published what is, I don't know, I've told you this before, it's my favorite paper of yours, and it was titled "Stable Internet Routing Without Global Coordination." And this was a real eye-opener for me at that time, because it described how AS administrators around the world can independently pick their local BGP policies while still allowing the global BGP network to converge. So in some ways, it was that reliability question, right? How you reliably converge upon a good routable network and the tables that you would need in each of the routers. I should point out to everybody that this paper barely makes it into Jen's top 20 most cited papers. But to me, it was a big deal because it helped stabilize the internet in a real practical way by providing principal guidelines to the folks who spent their days and nights trying to run it. So many people on the call probably never read, may have never read this paper because it's just such a long time ago. And if you haven't, I highly recommend that you do. But can you give us a quick summary of the main results as they were at the time? And then with the benefit of hindsight, what were the biggest takeaways for you?
So Li Gao, who's my co-author on that paper, was on sabbatical at AT&T, and we'd been working together on multimedia streaming, completely different topic, but she wanted to do something different during her sabbatical. And there'd been a paper also at SIGCOMM from Tim Griffin and others showing that interdomain routing could be unstable and that it was actually quite difficult to even ensure that it would be stable. Each network is picking its best path based on the options its neighbors makes available to it. And that can just go in circles. I pick my best choice. That makes you change your mind. That makes the next person change their mind. And there's oscillation. And we sat there during Tim's talk thinking, do you think this really happens? And we thought, gee, it can't, because there would be chaos if it was happening. And we had access to AT&T's configuration data. So let's go look and see, how is the network configured? Do we think we're only looking at one node?
I see.
Right? So we're not going to be seeing everything, but we wondered maybe there were design patterns that were in the configuration data that would tell us maybe configurations are not like this. Mm-hmm. And that started there AT&T has peers and providers and customers as business relationships. And as we started the model, well, where does the money go? Money doesn't go in circles. And maybe if money doesn't go in circles, the routes don't either.
I see.
Right. That so led us to start modeling. So you described it as kind of prescriptive. To configure your network a certain way, things will be stable. And that's true. But I think for us, we were thinking a bit more descriptively. Like how do
people actually do it? And so why did it work? Yeah.
Yeah. How is it that AT&T decides who they tell about their routes and how they pick the routes? And it's based on the money. Right. And then we thought, if everybody else is doing it, a rational actor like that, how would the emergent behavior look at? And then it's much more constrained. And the punchline is, if everybody's doing what's selfish, everything's fine. I see. Because money doesn't go in circles.
And similar paper that came about a little bit later, but really in this idea of trust and reliability for the internet was RCP and the routing control platform, and that really presaged much of the later OpenFlow and SDN work and network virtualization, et cetera. So to what extent, again, casting your mind back to that time in the context of that time, to what extent was RCP informed by or about solving AT&T's problems, the direct problems of those network administrators? And can you remember where you thought this was leading? Because with the benefit of hindsight, it was so prescient with what came later to do with ossification and all the ideas leading through, clean slate thinking for the internet. Do you and your team think at the time that it was going to define how AT&T's future network was going to be built, or was it really a research contribution to this sort of budding idea of change of control?
At the time, it was very focused on AT&T's problems, and we had been taking, the network protocols AT&T runs and kind of imposing management on top, tweaking configuration of BGP or of intra-domain routing protocols like OSPF, and it was so frustrating. I mean, we were developing these tools that were reverse engineering how the protocols worked and inverting them so that we could tell them how to be configured so that they compute the right answer. So, there was a lot of unnatural acts being done to coax the network into doing achieving a high level goal that we had for the network. And after a while, we're like, golly, the software base that we're accumulating, we've got this huge software base on the router, and we're creating another one to reverse engineer and control it. Golly, where is this going to lead? This is going to lead to this massive code base, and we're constantly worrying, do we have every detail modeled right? And, it was very painful and kind of maddening, right? Because sometimes we would be like, okay, we know what we want the router to do, and we're not allowed to tell it. And AT&T spent more money on network equipment than any other company in the country, and we're still not allowed to tell the frickin' router, like, what to do. Right? So it was a little bit of we're starting to get annoyed. And I was talking with some of the bellhead folks, if you will, about these problems. And they said, well, there's this paper from the 80s on the telephony network, on the network NCP, they called it, the network control point.
Okay.
Go read these Bell Labs technical journal papers. And I'm like, oh, God, it's another bellhead telling me and yet another story about how great the phone network is. And then I read these papers and I was like, oh, we should have a logically centralized stored program computer that tells the distributed set of telephony switches what to do. And I was like, wow, what a great idea. And then the question became, if we were to do that in the internet setting, what would that mean? It wouldn't mean the same thing. It would be setting up telephone calls or doing caller ID or call forwarding. It was a completely different set of applications. But then I started thinking about what would that mean and translated into these route control problems, traffic engineering or planned maintenance, all the kinds of things we were trying to do in unnatural ways. And it was really, and that's why we call it the RCP, sort of a nod to that paper from the 80s around the network, the NCP. It was just to think, oh, well, if we had direct control and centralized direct control and visibility, what would we do? And then it became a kind of systems challenge. Can we really do all that on one computer? And that became an engineering problem to figure out, how do we do all the computational work? And then Moore's Law was our friend. A single modern computer had more memory and CPU than hundreds of routers combined that were a few years old in AT&T's network. And that and a little bit of good engineering tricks, you could do on a single computer the computation for the whole network.
I want to see if I could pick something that we might not agree on, right? I'm going to try and come up with some things too. I may fail. So in 2014, you wrote a really widely cited paper that was entitled The Road to SDN, an Intellectual History of Programmable Networks. And that was with Nick McKeown, you just mentioned, and Ellen Zagura. So the paper, it kind of walked us through what must have been a fairly difficult tightrope to walk at the time, as it sort of tries to tease apart what were the historical trends and the ideas that led to this thing that got called SDN, which, as we know, is ill-defined and a kind of an amorphous blob. And there were indeed many folks who saw the pitfalls of letting the router vendors sort of keep their boxes closed and proprietary. And in the 1990s, there was lots of the DARPA-funded work on active networks. And there were many of us that thought that this approach of, for example, in one version of active networks, packets would carry programs that would then run on the routers. It wasn't the only way that it was, being manifested, but this is a sort of the one that became the poster child for active networks in a way. And many of us thought this was wrong approach, had too many performance implications, too many security implications, and it seemed really unlikely to be adopted. And in many ways, OpenFlow was about trying to design with adoption up front, and we're not really therefore kind of inspired in the positive sense by active networks. We always used to say, correctly or incorrectly, it was kind of more inspired in the negative sense by it, in that it was a fixed, simple, not programmable way in the data plane. Am I being too nitpicky? What do you think about this?
I think that's fair. I did find active networking more inspiring. You do say in the negative sense, and perhaps that was true for me too, but I think that's good, actually. I mean, when I was at AT&T, all this active network stuff was happening, and I was watching it from the sidelines. It wasn't really so germane to my life, and I was intrigued about wanting there to be a unified way of thinking about network functions and having greater programmability. But I was concerned with, well, who's the programmer? To me, it should be the network operator, because again, I was preoccupied with that user in mind. And why wasn't that the person who's the user or the programmer instead of the end user? And I was worried about performance because, again, I was in a very sort of practical mindset. So I think, like you, I was thinking about it in the negative. But some other things that came up there, I think one is the lighter weight form of active networks is exactly what Planet Lab is. Right, a header in the packet demultiplexes you into a program context. And in fact, Larry, when I asked him about it, said Planet Lab came out of his desire to do active networking in a practical way.
I see. Yeah,
that's sort of one thing. Jonathan Smith, who was very active in the work on active networking, really thought a lot about programming languages researchers connecting with networking researchers. He's the person who introduced me to my own colleague at Princeton, David Walker, and got us contact. And so who knew, how could I have been working on programmable networks since my PhD and not thought that PL was something I should have been paying attention to? It was kind of one of those moments, but Jonathan really, in his active networks work and in his own sort of recruitment work with me, got me thinking, oh, I should really be paying attention to these programming languages researchers and what they're doing, because it'll help. No, so again, the platform's not the same as active networking, but virtualization, programming languages, who should the programmer be, how to make it performant. For me, I was influenced a lot, maybe in some cases reacting against, but in some cases pulling disciplinary threads that I found really helpful in my own work later. So I guess I have a positive spin even on the negative reactions, if that makes sense.
There you go.
And there were positive things too around the disciplinary hooks.
And of course, those links with PL and Dave Walker and Nate on the formal verification side, et cetera, really pulled together a lot of the power that came from once you've got something which is, a system or a network that's designed like a distributed system rather than a collection of protocols, you can start to think and reason about these things. And, I think that's been a real eye-opener for both of us and really influenced.
Something like networking is about scarcity and about expressiveness, which seem at odds, right? A lot of work, whether it's on optimization or on compact data structures, it's all about trying to work with in a scarce, limited resource environment. And then you've got network operators who want expressiveness. They have so many things they want their network to do. And finding this sort of connection between the resource scarcity and managing resource scarcity and managing the desire for expressiveness and getting it just right. I found collaborating with optimization and algorithms people on one side and PL and verification on the other. That's defined my time at Princeton, are those sort of pair of connections with other fields that I didn't realize were so important earlier in my career.
I've had the great pleasure to witness some of your really legendary mentoring skills, particularly for women who are studying for their PhDs in networking or any area of computer systems. Several of my own female PhD students have reported that they wrote to you to ask questions. They didn't even know they were doing this about all sorts of things. You replied almost always the same day at length, no matter what the topic. You write lengthy recommendations for people, and you contribute ideas to what they should be doing, always encouraging and always pointing them towards new opportunities. And I've heard this from many women in our field and from women in computer science more broadly, from all sorts of universities as well as at Princeton. I have enormous admiration for how on earth you do that so easily and giving so freely of your time. This is something that, just to embarrass you, everybody who knows you says this about you. I asked a few people, so, what should I ask Jen? And this came up again and again. So it makes me wonder about your journey as a woman finding her own way in a male-dominated field, how it must have shaped in some way, and how it led you to devote so much of your time to helping out those who followed.
Well, first of all, I was just really fortunate to have amazing mentors. I mean, Albert Greenberg, I've mentioned multiple times, Farnham Jahani and Craig Partridge, yourself, Jim Provost. I mean, so many people that devoted time to helping me. So some of it's a pay it forward kind of thing. I also find when people ask these questions, I'm sure you feel this too. If someone comes up to you at a conference and asks you a meta question, or even the questions you're asking me now, like it's a moment for introspection, and the process of answering the question is the opportunity to be asked the question is a gift too, because it forces you to stop what you're doing and lift up.
That's very true.
And writing is thinking for me, right? And so I don't always start intending to write a long response, but then I get so into it because I'm like, oh, that's such a good question. It's so interesting, and I get into my head about it. So it's almost I would almost call it journaling.
I see.
That makes sense. Sort of in response to someone asking, and maybe wanting advice, but it turns into journaling.
You also have the benefit that you type really fast. I've watched you type. A little secret. I was a Kelly girl for a summer. Oh, wait.
I don't know if you know Kelly girls were this stuff now, but they're this typing crew, and I had a summer job as a cleric doing clerical work, and government memos were written in WordStar in the late 80s, which was the editor used for Turbo Pascal.
Okay.
So I was in high demand because I could type fast and I knew WordStar. And so I was sent out into all sorts of incredibly boring jobs that required fast typing.
So as well as being a pioneer as a woman in a male-dominated field, you've also been a pioneer as an openly gay woman in computer science and electrical engineering at a time when, there were so many obstacles and prejudices. Now, some of those obstacles feel like they're coming back again right now. But can you talk about your experience and what you've had to overcome in your career?
Yeah, it's interesting. I always felt that being a woman in computer science and being a lesbian were like one happened at work and the other happened outside of work. And because the gender imbalance in the field was such the dominant thing, that the sexual orientation thing was always second order. And I think especially in the early part of my career and my early part of my personal life, I was more compartmentalized and, the work and non-work. And I think one of the joys of caring less what other people think is you don't feel the need to compartmentalize your personal life from your professional life as much. And then you get to know people better and everything's a lot more fun. But I think I experienced the gender aspects of the male-dominated field. And in some ways, ironically, could be one of the boys a little more easily. And so there was some, I don't mean to say that it was all positive, but there's an aspect to being one of the guys that I've always enjoyed, and whether it's office mates in grad school or group mates at AT&T, that I found in some ways almost that was easier in a way. And I experienced, I did a lot of, volunteer work along with my now wife in LGBT issues. But I always thought of that as like, that's my outside of work thing. Inside of work, it's women in STEM. Outside of work, it's LGBT rights. And it took me a while to realize I was like split braining that. Because they obviously both matter to me, but I had sort of different lanes.
Now that you're in a leadership position at the university, presumably these sort of silos and partitions between different parts of your life and different parts of the world, they're all going to get smushed together naturally just because of the immensely broad things that you have to think about, work on, figure out for policy and budgeting and all that kind of stuff that happens in a university.
Yeah. And when I talk to LGBT groups, I talk about compartmentalization, right? That's often a coping skill. For dealing with a culture that's not accepting, right? People compartmentalize to avoid having to deal with things, and that getting past compartmentalization is a big part of the journey.
I must say, and this is something else that several people have said about you. This is a gen therapy session here. You always make it look so easy from one success to another. Yet, most of us go through periods of feeling down, frustrated, pissed off. And, times when our imposter syndrome is in full force. I know it's happened to me. And can you talk about your own experiences in that regard?
I mean, I've hinted at a few of them during earlier parts of the conversation. I think I thought my PhD research was on the wrong problem, right? So I had a lot of I didn't have good judgment in picking problems, right? That was sort of one. I think I felt at AT&T, gosh, I'm spending too long contorting myself around the technology we have now. I mean, you talked one thing I really admire about your work is you don't mind picking problems that the industry hates right now. Right. And I think that I think I've gradually gotten there, but that wasn't where I was. I remember when I first started working on this programming languages stuff with Nate and Dave, I remember someone in industry saying, well, Jen doesn't normally do things that aren't sensible. So this stuff seems crazy, but it must not be. I was thinking, it's not an insult or a compliment. I'm not sure.
Right.
But in a weird sort of way, it actually got more people willing to pay attention because they assumed it couldn't have been too crazy if I was,
Of course,
if I was doing it. But I've sometimes been a little risk averse in that way, where I do find sometimes the here and now a little more compelling. So that's a place where sometimes am I taking enough risk? That's another. I think a third is that I work a lot with other people who are experts in wielding a particular disciplinary hammer, whether it's programming languages or verification or algorithms. I'm very rarely the expert on anything that my papers are about. If you look concretely for what is the key disciplinary hammer. So sometimes I wonder, maybe I need a hammer.
I've witnessed some collaborations that in a good collaboration, everyone feels like that.
Yes.
Because everyone is learning from someone else and everyone's in awe of what so obviously comes easily to everybody else because that's their discipline and their field, but they're actually usually thinking about us too, I hope.
That's a good
maybe I'm a freeloader. I don't know.
Yeah, so I think when I have imposter syndrome, it's like I'm bringing a lot of people together, but am I actually doing something that's technically deep, right? So sometimes is there technical depth in what I'm doing or not? And then sometimes I think, well, it doesn't matter if the work comes out well. It's not important, actually.
I think the great thing about a conversation like this is that it becomes a bit of a surprise to people that someone for whom has had great success has all of these questionings of what they do. You heard it first here. Jen just said that she felt that she was risk averse. We don't think that about your papers, but your questioning, and that questioning, I think, serves a great a great service because it always makes you examine why you're doing something and am I doing the right thing and how can I do it better? And I think that although we often think of it as a negative, the fact that we kind of get, oh my gosh, I'm worrying about this thing. We all do it. And then how you channel that into saying, well, how can I do it better?
Yeah, I think I tell my grad students often the key is to fall in love with your work, but not so much that you're afraid to criticize it and yet not be paralyzed by the criticism, right? It's a delicate balance, right? Where you need to be harsh and receive harsh criticism from others, reviewer B or your advisor or whatever, and often from yourself, and yet still keep going, and yet also and not be so in love with your work that you don't accept any of the criticism.
I want to talk to you about running the university. It's always seemed obvious to me that you'd end up in a big job like this. You always had the vision, the people skills, and the frank, straightforward nature. Actually, when you seem unflappable when thinking about problems. So we needed someone like you running the place for sure. But Provost at Princeton, my God, that's a pretty big darn title and responsibility. Can you tell us a little bit about how you decided to go into university leadership and a little bit about what your daily life is like these days?
I mean, I think for many people, it's a bit of a slippery slope. I was, director of graduate studies early in my time at Princeton, and then I was acting chair, and then I became department chair. So these things all happened in baby steps where each time I'm like, okay, well, that was interesting, but I don't want to do the next thing.
Sort of boiling the frog, yeah.
Yeah, exactly. It's a little bit of that. But I will say, I mean, not unlike the research work I do and the community service work I try to do, I really like creating platforms, whether that's, technical platforms on which programmable networks run, or I like to be infrastructure to create. Mm-hmm. I tell people when they ask what I do in my work, I say I'm an internet plumber. I really like to think about the infrastructure, and all these academic administration roles are like that too, right? You have these brilliant colleagues or brilliant grad students, and you're trying to think of how can I do something that's, again, a lever that I can do a little work here and make a whole bunch of other people more productive in what they do. And so I think what I'm finding rewarding about the provost job is it's on a much larger scale and causing me to have to learn about parts of the university I knew zero about before. But it scratches that same itch of like, well, what's the intervention I can make that will unlock something that let them do great things. So there are amazing people all over the campus that if I can unblock them in some way, I'm getting more done than I would get done myself.
But it must mean that you have to deal with things that are really either mind-numbing or frustrating as hell, that you really wish that you didn't have to deal with, or things that are just probably really tricky to navigate, things with protests, things with big budget changes, government changes, all that sort of thing that, you know, it's like a first experience of like, how, okay, it's easy to sit in a chair in a faculty office and throw stones or, tomatoes or whatever people are doing, but actually then to have to make the decisions, that must sometimes be super taxing and frustrating.
Yeah, it can be sometimes a little lonely because there's a difference in the relationship. If you have colleagues too, right? Because now you're on the when you're a department chair, I think people think you're taking one for the team, and then I think once you're in any role kind of higher than that, you're there's a little bit more skepticism. Like, okay, now you're an administrator, you're not one of us, and there's a little bit of I would say that's one of the harder things, and not being in the classroom, I miss teaching quite a bit. Mm-hmm. But I think that what I've really appreciated is that the other people that are in these kinds of roles at the university we're all part of a team, and it's a little bit of that same interdisciplinary thing. It's like, gosh, our communications or government affairs or legal person, like they're experts on distilling a complicated situation of the type that you're describing. In some cases, it might still be my decision or my working with the president on a decision, but I've got these experts who have the hammers I lack. And it's often like, wow, that's really interesting. Like, that's a thing. I didn't know that. I mean, I knew it was a thing, but I didn't understand the art and insight nuance of it in a way that I've been learning so much of the past 2 years. AI for networking or networking for AI? Both are interesting. I'm more interested in networking for AI because I think we're plumbers, right? So we make things run better. So what was your? But I think that we can't make the AI for networking work well unless we have the right measurements, right? I mean, if you don't have the right data, AI is not going to help. So absolutely, you got to solve the telemetry problem first, and then we need networks that are amenable to being AI managed before we can really do the AI. Great point. So what was your biggest mistake or failure in research, and what did you learn from it? I think it's been sometimes spending too long close to the ground. I mean, to our conversation earlier, that there are times where I think that's useful as part of the learning and part of having short-term impact, but figuring out when to zoom out. I wouldn't say it's any one paper. It's more, when would have been the right time to zoom out? And sometimes I feel like I zoomed out late. Which paper that you wrote or a co-author on that when you read it now makes kind of cringe with regret? And just to set the tone here, I'm happy to tell you mine. I wrote this paper in 2002 with a student called "Is IP Going to Take Over the World of Communications?" I'd like to say it was tongue-in-cheek. It wasn't really, and it just makes me cringe when I read it today or I think about it. Is there one in your past like that? It's, again, I think this set of papers that maybe were a little close to the ground. There's a paper that I wrote with a number of people when Hui was on sabbatical, looking at if you take the forwarding policies in a bunch of network devices and compose them together, like what is the network doing? But we didn't have like an open flow-like clean model of what the data plane is. And so the model just was super complicated, in terms of trying to realize what the forwarding policy for the network was, because we were looking at the protocols that existed today, not at the data plane. And then when things like space analysis, Veriflow, and all that, I'm like, like that's so much cleaner. Can you say something about no coaches? Yes, everyone should have one or two. Someone that you go to that tells you that you shouldn't do something you're thinking of doing. And the introspection that provides. I mean, you were my no coach. I didn't go to you often, but I invoked you often. Like, I need to write Nick and ask, should I do this? And as I tried to write the note to you, I thought, God, this is so obvious. I shouldn't do this. I'm embarrassed to even ask my no coach. So I think having some discipline to not say yes in real time, to introspect a bit, and if needed, have someone make an intervention to keep you from harming yourself. So I learned about this from Jen, and we agreed that we would be each other's no coach. And so I had exactly the same experience. There were many occasions where I thought, I need to ask Jen. And so the idea is you ask them, and then they can say no on your behalf or tell you you'd be crazy to do it. And most of the time, as she says, just the question of thinking about it and being slightly nervous that you can say, duh, it's so obvious that you shouldn't do it. That you should say no. That wouldn't even say it. a mandatory waiting period before saying yes is already helpful, because my knee-jerk reaction, especially if someone asks me in person and it's a worthwhile thing, I'm like, yeah, sure. Then you have to learn to train your lower brainstem to say, that's an interesting opportunity. I want to think about whether I have time to do that justice and get back to you in a day.
Jen, thank you. I wish we could keep talking for hours. In fact, I'm pretty sure we could talk for hours if we could. I hope that even though you're now a big muckety muck with a big, great big Vancouver job, that you're going to continue to do networking research and stay in touch with us. And but finally, is there anything else you want to add before we finish up?
No, I think thank you. This has been a blast. I've really enjoyed it.
Me too. Really enjoyed it. Thank you so much, Jen.
Hi, everyone. Hi, Jen. Great to see you.
You too.
And just so everyone knows, clearly that was pre-recorded. We pre-recorded that at the end of February, and we did that so that we could easily fit within a 40-minute slot, because otherwise we'd tend to ramble on a bit too long and there wouldn't be time for questions. So we're going to jump into some live questions right now. And the first one I'm going to ask you actually is about this book, which hopefully you can see on the screen and hopefully isn't backwards like it is on my screen. So Jen and Pamela wrote this book that many of you will have seen, and I'm saying this to plug it so that you all rush out and buy it right now. It's called The Real Internet Architecture, Past, Present, and Future. And by the way, congrats on the book. I really enjoyed reading it, as well as one of the drafts along the way. And instead of teaching us about how the internet works from the bottom up or from the traditional layered model, it takes this modular framework as a way to capture how the internet really works in practice today, warts and all. So it's a really interesting way of thinking about the internet. Can you give us a quick synopsis and why you wrote it and how we could use it for teaching?
Yeah, the book came from several things. I think one is just as we try to teach undergraduate networking, and I'm sure you experience this too, there's just so much material to cover, and it grows and grows and grows. And there's this sense that we're talking about the same things just in slightly different ways at different layers in the protocol stack. There's only so many ways to route or to build a directory or the many things that we do. And so looking for design patterns that are a bit agnostic as to which layer they're at in the protocol stack, that was sort of one driver. A second is just that the 4-level stack of, Ethernet, IP, TCP, and application layer protocols is really inconsistent with what we actually see when we look at a packet. If we airdrop into the middle of the network, where it may have 10 or 11 or 12 headers because of different tunnels and protocols and things that are going on. And so we wanted to find a way to talk about the network that was responsive to where it's been, where it is now, and where it's going, without being wrapped up in the minutia of individual protocols and mechanisms. And so we were looking for a way to think of the network recursively as a bunch of sort of fatter layers that are each solving these sort of routing and directory problems, perhaps in different ways, and snap together, looking for sort of modular ways to reason about the internet. And that was sort of the genesis of the book. So it really brings Pamela's background in software engineering and verification to my sort of more low-level domain knowledge of networking.
And have you used it for teaching? There are many people who teach classes, I think, online. So have you had experience using it in the classroom?
A little bit. So Pamela taught a course at Princeton a few years ago based on a sort of early version of the ideas. And I've brought aspects of the book into lectures that I've given in the past in terms of trying to unify how we talk about directories, and whether it's DNS or Mac learning, and likewise for routing, to try to at least talk about things in terms of design patterns and in terms of the way layers snap together. The book came out after I'd already moved into my provost job, where I haven't been teaching. So I'm looking forward to getting back in the classroom and trying it again. But we know some colleagues that are starting to use it for courses next year. So we're looking forward to collaborating with them as they explore using the book.
Great. So let me take some questions from the floor, so to speak. So Shirley asked, regarding self-driving networks, should we focus on using AI, specifically Gen AI?
Yeah, so I confess I'm not really an AI person. I guess, like I said a bit in the chat, my biggest worry of using AI is if you don't have the right data, it can easily be garbage in, garbage out. And so I think getting the right telemetry data is so important. And it's not a trivial matter of just observing every packet. These AI algorithms aren't going to be able to run at packet timescales. I mean, you can't even do division and multiplication in the data plane at those kind of speeds, let alone run a neural net. And so figuring out what's the right telemetry data and the right aggregation of the telemetry data so that AI can run. So I think AI is promising if we can deliver it what it needs to be able to be effective.
Yeah, no, that's great. I mean, generally, and there are a few questions along this theme, which you touched on in the interview, but I think it would be good if you could expand on it a little bit. And that's this, the use. You and I have both spent quite a bit of time thinking about how you can use measurement plus AI techniques in order to understand the network better. But of course, there's also the great importance of the high capacity networks that are being built for training systems and for low latency inference systems too. And you compared a little bit of that in the interview, but any thoughts on topics and areas and things that you think would be interesting to work on in either of those?
Yeah, so here you mean more networks for AI rather
That's
than.
right. Yes.
Yeah, no, I think this is an exciting area, and there's nothing like rolling up one's sleeves and getting really into the depth of a particular application or platform to be able to do this work better. Whether it's dealing with feedback implosion, or a lot of these systems shard the work and then have a lot of communication overhead to get the data back. So I think I haven't done this as myself, but I think it would be exciting to get in the trenches with someone who's really trying to run one of these large scale training systems at scale. To be able to figure out, both what should be done in software distributed services and what lower portions of that could even move directly into the network devices, like whether it's data aggregation or better scheduling of co-flows. I think there's pieces of work that are already going on along those lines, but it'd be great to tie that deeply to a single application.
Yep. No, very good. By the way, some people are asking questions in the chat and some in the Q&A. Both is fine. It's a little easier for us to follow along if it's in the Q&A. So prefer it if you do that. And I'm going to ask one from there right now. Blake. Blake asks, do you foresee anything in the works that will enable the deterministic promises of Ultra Ethernet at layer 3? And do you think that this will continue to require new L3 protocols? And I think this is really in the context of the Ultra Ethernet Consortium. And, maybe I can generalize this a little bit. Everything, it seems, is called Ethernet, and now it's being relabeled and repackaged as something that would be used for interconnecting AI accelerators. And so, are we guilty of just reusing the name for things that are morphing over time? And any thoughts on where this goes for specific versions of Ethernet for AI systems?
Yeah, to your point about are we reusing the name Ethernet, it's fascinating to me that Ethernet is really a header format, right? There's so many early ideas. I tell my students what Ethernet used to be like when it was a shared medium, and they look at me like I have two heads, right? Who knew that the one thing that was hard to change was the header format, and so much has changed around it. I'm not close to Ultra Ethernet, so I don't know, but I think we can do a lot of clever things in the data plane if we have the ability to parse the headers and control the scheduling of packets. And these workloads really may demand precisely that kind of fine-grained control over forwarding and scheduling to be able to deal with the tremendous bottlenecks these applications could easily have.
So Ruslan asks a question of me, but I'm going to ask it of you instead. So, we've both in our lectures and talks, as many of us do when we're teaching, we try and tease out principles about the internet, and both in terms of its original design principles and how it's actually used in practice. Do you think this is still an effective way of teaching and thinking about the network? I think the question is probably in the context of when we teach according to the layered model. This is kind of getting back to your book, I think. It's quite constraining in a way. it represents the thinking of the time, and certainly you can think of layers as a separation of concerns and etc. But do you think that that's we're seeing the end of that way of thinking?
So I remember something Scott Schenker said many years ago, that the networking class you take in college is the only computer science course that's actually a history course. And I think there's an element of truth in that, because there is a sort of the network stack we have is a bit emergent from the accretion of ideas over time. I don't know if this is a good answer, but when I teach undergrad networking, I typically spend a few weeks at the beginning being faithful to the stack, getting through Ethernet, IP, TCP, and HTTP at just enough level that I think someone can understand how, when they click on a URL in a browser, how does it get down to the packets and back up again? Because I feel if you don't understand that, well, first of all, that's what many of them want to learn. But once they have that, then it becomes easier to have these more conceptual conversations about routing is taking place at every level, a frame or a packet or a message, some sort of thing with a format and a protocol is happening at every level. But if they haven't seen any of that, those conversations can be so abstract. But once they've seen them, then you can talk about routing, directories, distributed resource allocation in a more principled way, because they've got some place to hang their hat. And so I tend to use that layer stack approach for a few weeks, and then switch to the conceptual, and then switch to use cases, because like networking in the data center is so different than networking in a cellular edge or in a backbone. And so I think there's another sort of more like law school doing case studies of different kinds of networking scenarios where those same issues play out. Once they've got the knowledge of the internet stack and a knowledge of some of the concepts, then they can start thinking about how to apply them in those different settings.
So John asks about John Day, and you referred to John Day's work in patterns in network architecture, and he was clearly quite a pioneer. You say a little bit more about that way of thinking?
Yeah, Patterns in Network Architecture was an inspiration for the book that Pamela and I wrote. And when it first came out, I was so excited. I thought, oh, I'll use it for graduate networking text. And then it was frustrated that it wasn't quite accessible enough to someone who didn't already have a fair amount of background. So I learned a lot from reading it, but wanted to do it in a way that was a little more formal. And that's the perspective that Pamela brought, where we could be a bit more concrete and precise in talking about the ideas, but certainly a huge inspiration. And I think coming from the same place, that we want what we do to be a little deeper than the total sum of all the header formats and protocols that we know and love.
Yeah, no, I love that. So it's funny actually that I remember looking at the same text and thinking, John Day's text, and thinking, this is a wonderful distillation of principles, but and ways of thinking. But it just felt as though as something to use for teaching was a little of a collection of anecdotes through the lens of hindsight. And so this is one of the things that I think you did really well in distilling that with Pamela into something more formally structured. And I think it gives something more concrete for people to hang their hats on. So another John asks, says, thank you for the presentation, and thank you, Jen, for being so patient as I asked you all the questions. For anybody that wants to see a longer version of the same video, we're going to show at the end of this a URL on YouTube where there's the full 1 hour and 20-minute version that we cut down to about half size for this presentation. So John asks, what are your thoughts on digital twins in networks?
Oh gosh, I don't know if I know enough to answer that question, actually. I don't know, Nick, if you have thoughts about that.
I think if you think of a digital twin, in a networking context, I tend to think of it as the model that you can build of what's happening in real time, just based on a model of its behavior coupled with data and measurement at whatever granularity that you can afford to keep at this instant, in order to be able to have this this view of the network that you can poke at, prod at, be able to test out whether it's what would happen if you were to change and modify it, and to understand how it's behaving right now. To some extent, when you walk into a network operations center, as I'm sure you've done a lot more than I have, what you're seeing on the wall is the representation of that digital twin of the network, which you're either watching and poking at and observing in real time, or you can then take offline based on that measurement and say what would happen, do what if experiments based on that model. So I tend to think of it as of a newer name to what people have been striving to do, is just in this world of more measurement, the ability to capture more data, and then to use newer models in order to be able to analyze consequences. I think it's something that we should all be aspiring to as a way of thinking about networks and the way that they're managed and controlled.
Yeah, one thing I was struck by when I did a sabbatical at Google, gosh, it was probably about a dozen years ago now, is that when they needed to do planned maintenance on the network, they could take the same SDN controller software that they actually ran to control the network and then do what if analysis of planned events. And it hadn't occurred to me that logically centralized control would give you that, but of course it does, right? That there's no reason you can't do what if analysis on the same using the same code base, which is quite a really valuable aspect of SDN that I hadn't appreciated. So
Roland asks, I'll summarize his question in the Q&A. So do you think that the scalable zero-touch control plane connectivity is are we on a path to that we can have a much lower touch by humans and a much more automated control and management of networks? Yeah, I do. And I think, the logically centralized control of SDN is a way of making that simpler. It came up a little in the interview. I do think that the logically centralized control doesn't have to be centralized implementation. And I think that to me has been one of the more exciting parts of programmable data planes, is that ironically it's moving back to something more distributed, but hopefully with the idea that we want to synthesize that distributed implementation from something that's specified in a centralized way. I think that's the key to getting both the simple specification of what you want and the comfort that the distributed implementation of it is actually going to do that thing. And that those two things seem to be key to achieving that goal. So June asks, do you think that network devices should evolve to support more advanced computation beyond just basic operations? And are the current capabilities of the network devices sufficient? No, I agree. It'd be great to be able to do more. I think, Nick, this is probably a better question for you, but it's really, if you have to do something on every single packet, how far can you go at a particular link speed? That's sort of the constraint, but particularly for some of the AI questions people were asking, if you can't do the kinds of arithmetic operations that AI needs at the packet level, that's a big impediment. And certainly better encryption in the data plane would be necessary for a whole host of use cases that we just can't do with a lot of today's programmable devices that don't have some built-in crypto. So we started as hardware weenies, and we've made full circle back to thinking about the hardware and the network devices over the last few years. So I think there's a great place to stop. We're running out of time. We're at the top of the hour, and I just wanted to really thank you. The thing I really enjoyed about putting that interview together that we did back at the end of February was it was in the context of a very rapidly changing situation for universities in the United States with the current political climate. And I have deep admiration and respect for what you're having to go through right now and deal with. So hats off to you for taking that on. Princeton and the university system benefits greatly from your leadership. Thank you. So with that, I think we're going to pass it back to Christoph to round out.
Thanks a lot, Nick and Jen. It was a real pleasure to listen to you and to redevelop our own imposter syndromes. Listening to the conversation. Thanks a lot. So now I'm going to pass the floor to Serge. And Nick, I understand that you want to do more interviews.
I really enjoy it. So yeah, we'll do another one in the fall.
And we enjoyed it too, so you're welcome. Okay, thank you very much. I'm off. Serge.
Thanks a lot, Jen and Nick. A wonderful conversation. Thanks, Christoph, for managing. And as everyone was asking, it's very simple. If you want to join the session, it's every second Wednesday, 5 p.m. CET. And you can go to the networking channel website and you can register. The link is already available. And we're very happy that in 2 weeks, KK Ramakrishnan from University of California, Riverside, is going to handle a discussion with a wonderful panelist on the evolution of cellular networks. And Jim and I will be very happy to manage the logistics. So see you in 2 weeks. And remember to register. Thanks to everyone. Have a wonderful day. Bye-bye.
And have a nice breakfast, Nick.
Bye.